So just to introduce this, Rita, thank you very much for coming along to the first in our series of 30-minute webinars that we're going to try and run every couple of weeks. And the first one actually will be Lewis talking about our secret sauce, really, how we automate a lot of our development work that we do in DBT and Cube and Looker using some tooling that Lewis has developed and the team have been working on as well. So just to kind of set the scene, this is meant to be 30-minute bite-sized tips and tricks, really, about the modern data stack and really sharing some of the techniques and things that we use on client projects with the wider sort of world, really. So the format of this will be really, I'm just going to do a little intro now, then Lewis will be talking for about 20 minutes, and then we've got Q&A, right? So if you've got any questions, post them into the chat session in here. If there's any that we can't follow up on at the time, then we'll follow up afterwards and send it through sort of to the attendees in an email. And the next one we're doing is actually Amir is going to talk about how we build kind of modern data stacks using Cube, Preset, and Dagster. That's in 2 weeks' time. So that's the kind of next thing coming along here. But for now, we're going to be talking about how we automate development. So a quick plug for us: we're a boutique analytics consultancy based in the UK. We do full stack analytics development using things like Cube and DBT and Dagster and RudderStack. I'm sure you've heard of us before, but certainly our website is here. Click on that and you can get more details about us, really. But what I'll do now is I'll hand off to Lewis for the kind of main part of this, really. And we'll have your questions at the end. So, Lewis, do you want to take over?
Yeah, of course. What I'll do is I'll start showing my screen, doing a bit of a live demo in a moment. But first of all, what I want to work through are 3 talking points. First of all, what problems does our approach solve? I really want to set some context here about how we use this to accelerate the development for the businesses we work with and anchor it in some real business use cases. I'm then going to give a bit of an overview about how we do it. So for those problems, how does the tooling that we use, in particular Droughty, fit into the workflow? And they'll do a bit of quick talking about how much does this accelerate the delivery workflow. And actually, not only is it quick, but it increases accuracy as well. So it's not one of those trade-offs where you trade off accuracy for a quick development process. And then I'm going to dive into a quick demo about how we use this in a few different ways. I'm going to do a demo of us using it with DBT. I'm going to do a demo of it using Looker, Cube, as well as some machine learning capabilities we leverage as well, such as generative AI and machine learning models for entity resolution. So what problems does our approach solve? So over the last couple of years, throughout our customer projects, noticed an issue within the modern data stack. And really, one of the fundamental issues within the modern data stack is where it's a splitting together of the tools that used to sit within a monolithic solution, whether it be from like Oracle or IBM. Those where it's being taken apart, the different layers in the data stack don't work that well together on occasion. Examples of this are, it's that classical issue where you're doing dev work in DBT and those changes aren't naturally reflected within your downstream tools, whether it be Looker or Cube. So what we do is that we use Droughty in order to couple those different tools together to decrease the risk of regression is being introduced as you're working one of the independent tools. We also, whenever possible, try and make the cumbersome dry. So if there's ever something where it requires a lot of manual human input, we try and figure out a way of mechanizing that and automating it. And again, really, that is at the heart of Droughty because it keeps your workflow dry. We also use these tools to speed up the delivery so that analysis and activation of data is prioritized over the organization of it. And what I mean by that is by bringing in a lot of modern tooling, you can introduce a lot of engineering overhead if not done correctly. And you then spend the majority of your time remodeling data in DBT, reflecting those changes in Looker, and the actual activation of that data becomes an afterthought. whereas it should be the primary purpose of our workflow is actually getting insights out of the data that we surface. So we try and decrease the time that we spend reflecting those changes unnecessarily, and we try and make it as fast as possible. We also impose systemic testing, and we decrease errors through human input. And what I mean by that is doing repetitive testing is really boring, and it means that engineers tend to not do it or conveniently forget to do it. And by automating that process, you're increasing the chance of it happening. And by enforcing ruling around it, you're increasing the chances of it happening every time as well. We run a lot of these processes. I mean, you can run them as pre-commits so that when you commit work in Git, you're automatically imposing tests and running them in dbt, and then also building it into GitHub Actions so it becomes part of the CI/CD pipeline. So these systemic testing routines that we deploy are a huge gain, because especially when it's dealing with junior analysts, because they often forget to do these relatively rudimentary testing patterns, and it means that they almost can't forget. Another technique we use is we use generative AI to speed up documentation. So we connect to the ChatGPT API, and it infers long document strings to enrich metadata within our warehouses. And again, it's one of those things that engineers typically don't like doing. It's really labor intensive. It takes up a lot of time. And actually, generative AI produces far better long form descriptions than engineers normally do, although it does sometimes have interesting results. So it always needs a degree of QA, but it is a lot faster. Another problem that we solve is around entity resolution. And this is a big problem. When you've got multiple sources in a warehouse, it's quite a challenge to go through every single record and try and figure out which match which. And we deploy an entity resolution module that scans through all of them programmatically. It's learning, and you train it. And it means that when you've got one company from two different sources with a different naming convention, you can train a model to detect those changes, and it can save hours and hours of time, and it's far more accurate than the human way of doing it. And really, at a slightly broader level, what we're doing is we're embedding meaning into our models, not just ontologies. And what I mean by that is, in order for a tool like Droughty to work, a model and a workflow needs to be inferable, right? And we engineer in a way where the warehouse is easily inferred through semantic naming conventions, and it allows there to be this sort of like two-way input between things like ML, generative AI, and tools like Droughty, where it's almost like a living model. And through that inference, it can grow and stretch without everything having to be categorically imposed upon it, right? So really, they're the problems that we've gone out to solve. And we use Droughty in almost all of our projects now, wherever possible. And it really does accelerate the rate of delivery and decrease the amount of errors that occur. But it does require a sort of an understanding of a way of working. That's one thing that I'll caveat there. So I'll come back to questions at the end of the call, but I'd imagine this sort of sparks quite a few questions. In terms of an architectural overview, I'm not going to hang on this too much, but broadly speaking, the way that we typically engineer is we've got a set of inferable source models, such as Jira, Harvest, or something like Rudderstack. We've got entity resolution modules that sit within Droughty, which can bring these things together into one ontological entity, because if you had 3 companies in 3 of these tables, through the entity resolution, you can bring them into one, because categorically there is only actually one entity from 3 different sources. We then infer the semantic model based off the composition of that warehouse, and that allows us to automatically generate semantic layers in Cube, Looker, and other downstream tools. So from an architectural point of view, well, conceptual architectural point of view, that's really how it all sorts together. And I don't want to linger on that too long, so I'm going to move on to how do we do it. So that's the problem that we solve. But the way in which we do it is headless semantic layers. What I mean by that is, and I alluded to it earlier, is it's the ability for tooling to look at the composition of a warehouse and spit out the semantic layers for inference. So there's very little manual input. And just going into that in a little bit more detail, it's things like defining primary keys, creating measures, sums and counts, joins between entities. I feel all of that should be inferable and headless. We couple the semantic layer to the warehouse. So that's by generating that code. We're not writing a warehouse model and then reflecting that in downstream tools. They're really bound together. And we leverage technologies in Cube, such as transitive joins, enable to do that, so that we can get bi-directional queries. We impose the semantic aggregation through the definition of primary keys and correctly showing the cardinality between them as well through their relationships and joins. And we use the warehouse metadata to enrich the meaning of entities. So that's a bullet point list of how we're doing it as we work on our workflow. And the output of this is we can deploy modules, run DBT, produce cube layers, and then resolve entities in under a minute. So what this means is that you can go through very quick iterative cycles as you're developing content within the warehouse and bringing it through to downstream exposures. So what I'd like to do now is just do a bit of a run through of what this looks like in a typical workflow and give a flavor of how quick it is. So what I'm going to do is I'm going to bring up VS Code. I'm going to jump into a demo here. So what I've got in here are a few different sources. I'm just going to get rid of this float. I'm just going to stop sharing at the moment as well because I've got a robots file there. Here we go. Okay, so as a quick run through, what I'm going to do is I'm going to introduce a new model into the warehouse, and it's going to be called customers. Why don't we call this something like customers again? Customers demo. Yeah. So the first part of the workflow really starts with DBT. Well, it doesn't it? I mean, it obviously starts with the design of the physical model, but in terms of committing work into the warehouse, it starts with DBT. So our typical workflow would be using Droughty. We would bring through the model, and here we've got one called customer demos dim. So as I generate this model, it's going to run against a warehouse, and it's going to generate metadata within the warehouse that Droughty can read from. And it's going to, when it produces that metadata, it's going to give Droughty content to read from. So it's going to go through, generate it, and that table's now created. Now what we can do is by using the Droughty test module, we can start generating some tests. And we can now see them coming through in here. So in the schema, you can see that new tests have been generated, and it's also bringing through descriptions for those tests that we can automatically generate. And this allows us to now, as we're bringing entities into a warehouse, programmatically test against them. So now if we do a run, a test against that module, customers can bring that. Yeah. Those tests can run. So typically in my workflow, what I'll do is as I introduce a model, I go through, produce a model, and then test it as soon as I run it to make sure it matches my assumptions. You can see here already, we've got some really meaningful information starting to emerge. We can see that the primary keys in that table are passing. So that means that we're not introducing any duplicates, and there's at least one value. And if this was like a slowly changing dimension table or something, it would check that the lagging and the leading values are within the correct bounds. And this is also extensible. You can make modifications to Droughty to have more extensive testing patterns, but this gives me a generally good steer of what's happening. So now that I'm comfortable with this table and it has passed the tests that I want, I can then generate more content. So if I go through and I generate some look'em against it, this is now going to produce a look'em. And in this look'em, it's going to do a number of things. It's going to produce measures, and it's going to define primary keys, and it's going to pull through descriptions as well. So if we go through to this table in LookML, you can see that it's now available within LookML. And if you pulled this in through the UI, you'd then have this content available. And it's doing a number of things here. It will assign primary keys. It will also start to define drill fields. And where possible, it will start bringing through those automatically generated descriptions into the semantic layer. So already it's doing a lot of work that you'd have to do manually and automating it. So these drill fields allow end users through, because there's a routine that Droughty goes through to generate them, to then explore data through different levels of granularity. And it also starts to impose measures on it here. So it will look at the data types within there, and where appropriate, it will apply sums to it or counts. And then the base layer, it will start to define the base explores. So if we go here and we have a look at the table again, this is where you'll see the primary keys being allocated, any dimension groups. So already in the brief time that we've been using this, as we've introduced this new model, we've made sure that it matches our testing assumptions. And in addition to that, once we've approved that and it looks good to us, we're bringing it through into our semantic layer. Now, if you were using multiple semantic layers, you could equally do this for Cube as well. So if we now ran Droughty Cube, we'd see exactly the same thing happening. So in here, we'd get the Cube model starting to emerge. We're getting the aggregations in there as well as a series of extends. We're getting a very rich integration module emerging as well. And what this does is it starts to join together your warehouse models through inference. So now it's not only producing the dimensions for you with the primary key flags and the measures and the sums and the descriptions and any other enhancements, it's also linking that data together through inference as a semantic model, meaning that it can roll up and roll down and be discoverable for end users. In addition to that, you can see here that it's starting to define relationships as well. So look at the underlying structure of the data in it through its inference and start assigning whether it has many-to-one relationships or it belongs to something, etc., etc. And this is a fully explorable model that flexes with transitive joins. As another example, and I know I need to be conscious of time, but if I now run Droughty Docs, what this does is it goes through and it connects to the OpenAI API and brings through only new doc strings. So it'll scan through any pre-existing strings that have a match as a docs reference and ignore them. For ones it doesn't have a reference to, it will now connect to the OpenAI API and start to give you some generated descriptions in there as well. In addition to all of this, it will also start outputting ERDs of your model and all of their joins, and it will start giving you recommendations about orphan foreign keys, as you can see here. So when this is generated, it will provide a rich ERD of your data warehouse with the semantic inference as well. You can see here that it's starting to join together keys. So in totality, all of the models, apart from the DBT model that I wrote, have been automatically generated. And you can see that it generates thousands and thousands of lines of code. And this isn't bloat code. We use this as productionized content in almost all of our projects. So it really is useful production quality. It just really needs a human eye to watch over it and make sure that for the descriptions, they make sense. But everything else is perfectly inferable. So one last piece is the entity resolution. So I'm not going to go over this into too much detail because it's going to look into the commands we work with. But what will happen is a prompt emerges and you train a model within Droughty Resolve. And there's a customer that we've got a referral from here, so I can show it. But it will look through, when you run Droughty Resolve, 2 tables, and it will ask you whether it's a match, not a match, or unsure. And this trains a live model that exists for that entity resolution, and it feeds into a warehouse table that you can then use to link together entities. So here's an example one I made earlier, and you can see here that it starts to cluster together the same names or similar names from different tables. And this is what you can use for this layer in the warehouse for the entity resolution. So you can, in 10 minutes, generate multiple semantic layers. You can generate tests. You can resolve entities. You can bring through generative AI descriptions. You can generate working ERDs. What I'll quickly do is I'll actually show you that, so we've got almost enough time. So if I now copy this ERD, go into here. So I'm just going to copy the path, DB docs build. That ran first time. And in here, we've got a complete ERD of our data warehouse. So these are all things that customers really need. You need to test your data. You need to build out semantic layers. Well, you don't need to, but like if you're using a tool, you need to build with a semantic layer. You need to reflect the changes in the warehouse in it. It does an awful lot of legwork, and I will run Droughty several times a day to keep refreshing all of this and keep it fresh in line with my development changes. And then I take screenshots of all the content that I've just produced in a pull request to give the peer review, whoever's doing the peer review, important context, just to give a flavor of how complex those cube layers come out as, with the transitive joins that are automatically generated and the entity resolution that we committed to in Droughty Resolve. It generates really complicated, or what are quite complicated transitive joins with zero effort that just scale elastically with the input that you're doing within the warehouse. And you can see that SQL being generated here on the fly. And it's also very efficient because of the algorithm that Cube uses to generate its transitive joins. It always builds a relatively efficient model. And in the same breath, this would all be available, when you generate your looker as well. So if we go in here, we can see those base layers being developed. So this really does save a tremendous amount of time. It's something that we lean on a lot internally. It's something that we would like to build out further in the future. So any questions whilst in the last 5 minutes?
I'm on, hang on. So thank you, Lewis, that's fantastic. So anybody, I've actually unmuted you, or I've actually allowed you all to speak. So does anybody have any questions or comments or thoughts on what Lewis has just been showing?
Yeah, just wanted to ask, how does Droughty handle changes to your DBT model? Do it just regenerate everything, or is it smarter than that?
No, it will just regenerate everything. So what it will do is it will so it doesn't have a notion of, it doesn't look at the manifesting, for example, to record gradual changes. However, because it's looking through I think that the Droughty DBT module takes about 500 milliseconds or something to run. So by only recording gradual changes, the performance increase wouldn't be huge. Yeah.
On that point, Lewis, what was the reason? So we've often discussed why you generate this stuff from the data dictionary, from the information schema, as opposed to doing it from DBT. And that's because of the testing, isn't it? And as you do testing, is that? Can we just elaborate on that a little bit?
Yeah, I mean, so there are a few reasons why I don't use the manifest. It means that you can do diffs. So you can, with a manifest, there's a copy of a manifest. Whereas if in Droughty, and there's more features that will rely on this, you can look at multiple different data sets. So the benefit of that is that you've then got if you're trying to test things in different data sets, you can then do comparisons between them. In addition to that, it makes it tool agnostic. So Droughty works with lots of different tools, and it's not a tool for DBT. And if data form became greater in popularity, I would equally build out a data form testing feature or something. Yeah.
Any other questions at all from anybody at all? If there's not, I had one. Sorry, is that question coming through? Right. Okay, so I had one, Lewis, actually, which is how do people get hold of this? So you developed this tool and we use it internally at RA, but take it as open source? How do people find out more about it? And maybe just bring up the project page on the screen before you finish.
Yeah, of course. So it's GitHub Droughty. In there, so I've also sort of got the read docs as well. So in here, there's relatively rich documentation about how to set everything up. All of the dependencies in there as well. How to go through a configuration of it's very similar in the way that DBT set up, really. You've got a profile as well as a Droughty project, and you can store them anywhere on your local system, or you could, in theory, in a container as well. So that's the best place to go. The Droughty Git repo, and then all of the documentation is on Reader Docs.
Fantastic. And there's a link on our website as well, which has it on there as well. So thank you, Lewis. Fantastic for doing that. I appreciate it. It's the first one we've done. So thank you for being our sort of guinea pig on that. We have another one in 2 weeks' time, which will be talking about preset and Cube and so on. But until now, thank you very much, Lewis. Appreciate everyone coming along, and we'll make the video available afterwards as well, and the slides. So thank you very much.
Fantastic. Okay, thank you, everyone.
Cheers, and thanks. Take care. Thanks.